Hey, what's up, people? Alright, new day. Let's see. I accidentally changed the size of my font, and now I don't know how to change it back. Um, I know previously I could just do control and then up on the scroll wheel to do this, but apparently that doesn't work. So I have to figure out. So let's ask the God, ChatGPT, VS Code, let's see, keybinds for changing font size. I hate when they do this. Like, bro. Anyway, in Visual Studio Code, you can change the font size using the following keyboard shortcuts: zoom in, zoom out, control plus equals. Control plus equal. Wait. Yeah, control plus equal versus control plus minus. Okay. There we go. Well, that seems like huge now. I feel like it's jumping two steps and not one. Why does that seem like massive now? Whatever, it's fine. Alright, let's go over here to our extensions. Let's restart them. Let's go ahead and set our timer. We'll set it to 66. Alright, timer is set. Let's get our stream set up. I tested the audio, so I know the audio is good. Let's set our time. Alright, there you go. Our stream set up. Okay, it works. Okay, let's pick up where we left off yesterday. We stopped at line 101 in save logic. We continued / finished first pass revision converting save logic stable save state function 3 table system to a 3 file system. We virtually finished it, but we need to review it. Well, actually, like, we kind of did review it. I'll just give it one more review. Yeah, I don't really want to review it again because it's kind of a nightmare to read it. It's a lot, but I mean, I don't know. It's good practice, I think. So I don't think we need SQLite test open right now. All right, so let's just start from the beginning here, and we'll review what we have. So we have stable save state function, which takes checkpoint ID. Currently, we don't use checkpoint ID within the function yet, but we will. I think we will. Then we have save data stable path, which is a string consisting of ... double slash. We have to do double slash because of the escape characters within strings. And then database DB, which references this. It's supposed to reference this DB folder. So we have Canasta directory, and then we have within that the main directory and the database directory. So since we're calling this from the main directory, when we do ... it's going to bring us out to Canasta. And then we're going to go to database, which will put us in there. And then we're going to be looking for save data stable.db. And that is the correct, file type. Alright, so that's good to go. Then we have save data stable backup. and this does match. It's save data stable to save data stable. This is going to be save data stable backup to, well, if we highlight from the correct point, it should also highlight that. Yep, so we did spell it. They do match. And in this one, we just do .db / save data stable backup .database. So same exact thing, just with backup added. Then we have if OS path exists. So now we're checking to see if save data stable exists. All right. So we pass to os.path exists, save data stable path. And we verified this syntax is valid via test in test reminders.py. Now, if that path does exist, meaning that there already is a save data stable, which means we've already saved once before, at least once before, then we check to see if OS path exists for save data stable backup. So if the stable exists, we check to see if the backup exists. If both of those exist, then we check to see if the stable backup is integritous, whatever. I don't even know if that's a word, but whatever, I'm going to use it anyway. So if it's valid, which means our integrity check fetch 1 at index 0 would be equal to OK, that means it's good to go. So we can rely on that in the case that this process, you know, if it fails, we can fall back to that backup because it's good to go. So in the case that it is good, we do os remove save data stable, and now we can vacuum from save data, which is cursors associated with save data. We'll vacuum from save data into save data stable, so we make a copy of the new, you know, that new copy. There you go. Now we check to see if the newly created cursor stable, which is associated with save data stable, has integrity. If it's not integritous, then we would remove the save data stable path completely. We would just delete it and then redo that vacuuming into save data stable again. And we didn't put our double stamp of approval. So let's go ahead and add that. All right, let's go over here. Okay, now we have else. So is there anything else we need to do here? Well, in this case, we would need to make the new version of backup, but because now we have transferred from save data to stable, and we have a current version of that. We have an old version of backup. Okay, so in the case that save data stable exists, but backup doesn't exist. So this is a rare scenario wherein it was the first time copying from save data to save data stable and then crashed prior to running save data stable to save data stable backup. It's a very rare scenario. So in this case, cursor stable, we would check, well, we would vacuum into backup. So how do we know that exists? Well, because we ran the if on it and it entered into it. So that means save data stable does exist, but backup doesn't. So now we're accessing cursor stable, which is associated with save data stable, to vacuum from stable into backup to create a backup that never got made. Then after that, we check to see if the newly created backup is integritous. If it is not, then we would remove the backup path and then rerun the vacuum into the backup path to just recreate it. After that, we would remove the save data stable. And why do we do that? Why do we remove? Okay, because that's the old save data stable, right? And the reason we don't just put the removal, because we do remove save data stable in both this if and else, and you could say, well, why don't we just do it once, you know, prior? But the reason that we do that is because we do it this way is because we need to have it in the case that backup doesn't exist, so that we can create the backup based on that that stable. So we couldn't delete it prior to this else clause, otherwise we wouldn't have it, you know, to create a backup. Um, I'm I'm just like, well, honestly, reading this, couldn't we just actually vacuum into hear me out now. Instead of going from stable to backup here, couldn't I just do save data to backup? I mean, I know that's like out of order, but yeah, I mean technically it is out of order. Because then the stable would be older than the backup. And that kind of like breaks the unspoken rule that backup is a backup of stable. Um, so like reconnect logic wouldn't reconnect to backup. It would reconnect to stable. The unless we like check the timestamp of last update, that's something that we could do. To like remedy that issue, and then we would just see which one has the most recent the most recent save you know, saving which one was saved most recently, and then load from that one. Honestly, I'm just like, it's basically there's really not much different here. Like, technically, is it an improvement to go from save data to backup? I guess so. But you know, in that case, then we would so that would just change it to where whenever we reconnected, we would check the timestamp in each database to see which one was newer. So we just wouldn't have this unspoken rule that stable is always, you know, like directly a reflection of backup. Like if we have stable and backup, load from stable. It would break that rule to where one could be newer than the other. So let's just keep going here through this. So if OS path exists, if save data stable path exists, so if we have the stable and if we have the backup, then we're just removing the stable and creating a new stable. And then if it's not okay, we just redo it. OS remove save data stable and then vacuum into. Okay. And then in the case that we don't have the backup, I might change this to the way that we just described, where we would go from cursor to from save data to backup directly, instead of like copying an old version of stable. That's kind of silly because we're literally about to like recreate stable. So it's kind of silly, right? So I think we will make that change, and I'll put a note here that we're gonna need to add in our timestamp changed, or timestamp last save, or last updated, last save, whatever, timestamp last saved, for save data stable database and save data stable backup dot database. We need to add in that, since we sometimes will have backup.db being newer than stable in rare scenarios. So in this case, we would simply check what? We would simply check for save data stable database and save data stable backups. In this case, we would simply check the timestamp last saved row in each database upon reconnect to see which is the most recent. And let's think about that for a second. So in the case that, let's just say, even if we didn't have a most recent, like stable gets copied over to backup, but they're identical, but backup would be more quote-unquote recent because it happened after. So in that case, we would pretty much like always load from backup. I mean, but let's say like maybe it in a very rare case we transferred from save to stable, but it got interrupted before we could do stable to backup. So in that case, it would check to see which one was the most recent, and it would be stable. So then it would load from stable instead of backup. See, now, if we didn't have this timestamp check, then in that scenario, we would have we would load from, well, if we didn't have a timestamp check and we had both stable and backup as quote-unquote valid, like not corrupted, well, we would theoretically like have loaded from stable, but I think in the case that, like, I feel like this is a smarter way to do it. It's a safer way. It's not like an ambiguous, nebulous rule that has no logic behind it. Using a timestamp of last updated is, you know, logical, because in this rare scenario where backup gets updated, and then let's say it gets interrupted, like we have a current stable, but we don't have a backup. We need to have a backup before we redo the new stable. So what we're going to do is we're going to copy from save data to backup, make sure that one's valid and not corrupted, the backup that is, and then we can go ahead and delete the old stable and create the new one. Now if after we created the backup it got interrupted before we could go from save data to save data stable, save data stable might be not corrupted, but it would have an older timestamp because backup got updated with the new data and stable has the old data. So as long as we check that timestamp upon reconnect, we're good to go. So that's a smart decision. So we're definitely going to use this. We're going to add in this timestamp last saved. In this case, so it is for rare scenarios, but it's just the smart way to do it. So in that case, we would simply check timestamp last saved, row on each DB boring, which is the most recent. Yeah, straight up. And another thing I want to do, so we can have this. Well, let me go ahead and finish reviewing this first, just to make sure that the overall logic is good, and then we can deal with other things. All right, so where were we exactly? We were right here in the else, and we were saying that whenever backup doesn't exist, instead of doing stable to backup, that's an old stable, we're gonna do from cursor and then we're gonna vacuum. So we're vacuuming from save data to backup instead of from the old stable. We're going from the new save data, and this creates a backup first since we don't have one prior to vacuuming from save data to save data. Yeah, so it's the same exact thing. We're just changing where we vacuum from. Then we say if the cursor stable backup is integritous, or if it's not rather, then we would remove that save data stable backup path, and then we would run the vacuum into save data stable backup again, but this time we're going to change it to cursor, so it's going to go from save data to backup. And then we would remove the save data stable path because we now have a save backup to work with, and then we do cursor execute vacuum into save data stable from save data. Alright, so all that looks good. Now we have else. This means save data stable does not exist yet. This means it's the first time copying from save data to stable, and in this case we would vacuum from save data to stable. If the stable is not integritous, we would remove it and then redo that process going from save to stable. Now what about the backup? Well, in that case, in all these cases, in this else case, we need to create a new backup, except for this one, because we just changed it. So now backup is actually like good to go. A backup here is the most recent. Like, it doesn't need to be, we don't need to vacuum from save data to backup, which is what this section does. So what we'll do is we'll create a boolean which is called we'll just say already created new backup equals true, and then this will initially be set to false, So we'll initially have this set to false, and this is going to be a type bool. It's going to be purpose is to purpose is to used in rare scenario wherein backup DB did not exist, but stable.db did. Creates vacuums from save data database to backup database. And I might change these names to make them easier to read to just be called save data, stable, and then backup, because it's just so much easier to read. So we use in rare scenario where backup did not exist with stable database did vacuums from save data database to backup database. In that else clause, therefore doesn't need to happen later on. Therefore this boolean is set to true after this process or immediately prior to this process to indicate that we and then subsequently checked if still set to false, we'll create that new backup DB since it hasn't already been created. And that is that was a lot to say, but already created new backup false. So it starts off false, its type is bool, its purpose is using rare scenario wherein backup DB did not exist but stable DB did. Vacuums from save data to backup in that else clause, therefore doesn't need to happen later on. Therefore this boolean is set to true immediately prior to this process and then subsequently checked. If still set to false, we'll create that new backup DB since it hasn't already been created. Yeah, there you go. Alright, so we have this already created new backup set to true, and then down here we'll check and say if already created new backup is equal to false, then we will creating new backup is equal to false. Okay, so if OS path exists, save data table backup path. Okay, so then yeah, only in this case where created new backup is false, because we wouldn't need to do this if we already did it. We wouldn't need to check for backup because we know it exists, because like we literally went through that and created it and all that. So why would we remove it, and then why would we vacuum into save data stable, and then why would we check it to see if it's got integrity? We already checked to see if it has integrity whenever we create it, so yeah. Alright, so else, it's kind of hard to keep track of this. I need to put this stuff into functions because it's really like it's like an eye puzzle. It's hard to decipher looking at it. If already creating a backup is equal to false, if OS path exists, save data stable backup path. So then we would remove it. So only in the case that if this is false, yeah, because it would be set to true. if we already did it. Yeah. If backup DB hasn't been created yet, hasn't been updated with latest save data yet. Okay, that's good. We reviewed it. Let's go over here, and we'll put that we reviewed it and everything looks good. Alright, so now I think we're going to create this new function to just clean this up some, because it's like a lot of repetition going on here. So let's fix this. Let's do... So what are we going to put in the function? Okay, we're going to do the integrity check, and then it does remove... Well, there's one where we do integrity check to see if it is okay. So if stable backup is okay, then we would remove save data stable path, and then we would vacuum into save data stable. Okay. And then we go, so this removes, yeah, that's going to be different. The one that we're probably going to make the function for would be this one. If cursor stable execute integrity check is not equal to okay, then we would remove the stable and then redo it. So this is basically like a checking for the one that we just created, and like honestly, we could put the vacuum into in it as well, because all we're doing, I mean, we could put the, couldn't we put the remove as well? We could, it's remove, vacuum, and then we're checking it and then just redoing it. Same thing here. We would do integrity check, remove. Let me make sure it's exactly parallel though, because it has to be. So we have cursor stable backup, well, we don't have to do it for the equal to. We could do it for the not equal to, because we use that one 1, 2, 3 times. We actually use it 4 times. 1, 2, 3, 4. And every time we check it, we remove, and then we recreate it. We check it. Well, actually, really, we create it first, then we check it. Then if it's bad, we remove it, and then recreate it. So create, check, remove, backup. Create, or rather, create, check, remove, recreate. Same thing here. Create, check, remove, recreate. Okay. So yeah, I think we'll do that. So let's go ahead and create that function. Let's create it right before. So we're gonna have def, and this will be called vacuum into integrity check recreate. Yeah, because we're vacuuming into, we're running an integrity check on that thing we just vacuumed into. Or yeah, and then we're recreating it if it wasn't good. So it's just like a double operation to make sure it's valid. So we would say def vacuum into integrity check recreate, and it would have to take in it would have to take in the vacuum into path. Okay. And then it would need, well, we need the cursor as well, right? Cursor. You could say exact cursor. And then vacuum into path. So this would actually be cursor 1. We would need to pass in 2 cursors, because the first one we start with would be a different one. So we have cursor 1. That's where it comes from. So we can call it source cursor and then target cursor. And we can have that, those will be back to back. So it'll be like this. Source cursor, target cursor, vacuum into path, and then what else will we need? That's it, I think. Okay. So then we would, let's just copy this code directly. Alright, and of course it messed up the indent because that's what it does. Now, so we have source cursor. This would be changed to source cursor because this is where it's coming from. Source cursor, execute vacuum into, and then this would be the vacuum into path. And then we would have the target cursor in place of the cursor stable, because if we're going from cursor to stable, then that means we're going from source cursor to target cursor. So this would be target cursor, because we're checking the integrity of the one we just created, aka the target. And we would just do integrity check, fetch 1 zeros, done equal okay. So that should remain the same. And then we do OS remove, and this would be the save data stable path in that case, which would be the vacuum into path. So let's go down here to the vacuum into path. OS remove vacuum into path, cursor execute vacuum into, and that's the save data stable path as well. So we just paste that right in there, vacuum into path. And then cursor, this should be source cursor, right? Yeah, because this would be redoing the initial action. Yeah, so let's just review. So we have vacuum into integrity check recreate as the name. I think that's a good name. Then we have the 3 parameters: source cursor, target cursor, and then vacuum into path. I think those are good names and structure, and a good structure. We would then run from source cursor to execute vacuum into the vacuum into path. So if we wanted to go from save data to stable, the source cursor would be cursor, target cursor would be stable cursor, and then vacuum into path would be stable path. So we would say source cursor execute vacuum into stable path. That's correct. So it's going from save data to stable. Then we say if stable, aka target cursor, is not integritous, then we would remove that target path, vacuum into path. And you know, we might could use target instead of vacuum into. I think I would rather that. I like that better. We'll just say target path. So any vacuum into path is going to be replaced with target path. That's just, I like it better. It associates it with target cursor, which is cool. So yeah, now we have source cursor execute vacuum into target path. Then we have if target cursor is not integritous, then we would remove the target path and use the source cursor to re-execute right back into the target path. Yeah, so that's perfect. We'll make a comment for this. Needs to be tested, and then we'll just also put that it's below function, save system. It's created. I think we're supposed to put below function first. I kind of forgot the proper way. I like. It's just the way that I do it. I forgot how I normally do it. I think I do below function first, then the created date, and then anything else like to denote what we're dealing with. Yeah, so that's fine. I do like the dashes better than the colon for whatever reason. It just looks better. All right, and then we say params, and I use 1, 2, 3. So the first one would be source cursor. And this would be type would be cursor, database cursor, and then purpose would be the cursor from which we are vacuuming to another database. The cursor from which we are vacuuming to another database. Yeah, there you go. Alright, and then the second one would be target cursor. And this would be type database cursor. Purpose, the cursor to which we are vacuuming into. Creating. And then we have the final, which is called the target path. And the type of that would be string. It's a path. And then the purpose would be the path of the database file that we are creating via vacuum into. Yeah. Okay. Now and you know, this would probably be better done in a while loop. We would just say, so source cursor execute vacuum into, and then we would say new database has integrity, or new database isn't. Yeah, I know. New database isn't corrupted. Let's see. Vacuum into integrity check, recreate source cursor, target path. New database isn't corrupted equals, so it would be set to we'll say new database is corrupted, or we'll say is corrupted. No, because we don't want to say that. We want to say isn't corrupted. And that would be equal to, so if isn't corrupted, we would set it to false first because we don't know. Because it could be corrupted. So then we would say while new DB isn't corrupted is equal to false. Because if it isn't corrupted, that means if isn't corrupted is set to true, that means it's not corrupted. But since it's set to false, that means it might be corrupted. So new database might be corrupted, or we could change it to say new database might be corrupted. Yeah, we'll change it to that. That's better. New database might be corrupted. Because new database might be corrupted. Yeah. Or actually, verified. Let's do this. New database verified, not corrupted. Yeah. New database is verified, not corrupted. That means it's false because it could be corrupted. And then we would say while new database verified, not corrupted is equal to false. That means we haven't ran an integrity check on it yet. While we don't, like, until we know it's not corrupted, this is going to remain false. So we keep doing this over and over until we verify that the new database is valid. So while it's new database verified not corrupted is equal to false, then we would say if target cursor execute, so then we run the integrity check on it, and sip of water here. On the database verified not corrupted is equal to false. If target cursor execute, always remove target path. Then we would say source cursor execute vacuum into target path. So if it's not okay, then we would remove it and then redo it. But if it was, meaning if it is not corrupted, then we would change new database verified not corrupted equal to true. Now we know it's not corrupted. Yeah, so that will break out of this while loop. Once it is found to be integritous, it would go to the else, and then we would change new database verified not corrupted to true, and then yeah, that would break out of this new database verified not corrupted equal to false. Else is if it is not corrupted. Because if it's not equal to okay, that means it's not good. So if it's else, that means it is equal to okay, which means it is good. So that means it is verified to be not corrupted. Yeah, buddy. Okay, cool. So that function is done. Now we can go ahead and implement the function. So what we'll do is we're gonna don't we have to create the cursor as well? We'll worry about that in a second. Let's see. So let's go ahead and replace the code with vacuum into integrity check recreate. So let's go down here to where we vacuum into, let's see, where's the first case of this? I guess it would be right here. So consider putting it into, yeah, alright, so we're doing that. We already did that. So right here we have cursor execute vacuum into stable. So it's going from save data to stable. So comparing that with the function code, that would be source cursor vacuuming into target path, which would be stable. Then it would do new database verified not corrupted equals false because we just created the new one. And then it would be while new database verified not corrupted equal to false. If cursor stable, which would be target cursor, was not equal to okay, then we would remove the target path, which is stable. Right, so that would be OS remove target path in the function. Then we would do cursor, aka source cursor, in the function, vacuum into target path, aka stable. So this does mirror exactly. So we can go ahead and replace this code. So we start here with vacuum into stable from cursor. And we're going to just highlight all this. And then we're going to add in vacuum into integrity check recreate, and we have cursor as the source, and then cursor stable as the target cursor. So then we would say cursor, and then what's it called? Stable cursor? Cursor stable. And then, so cursor stable, and then what else? The target path. And the target path was the save data stable path. So I'll just copy that. Bam. There you go. So now we have one line instead of like 5 or whatever. Vacuum into integrity check takes cursor. So let's read this. Save data stable. If stable and backup exists, then we check the integrity of stable. If it is, we would remove the stable, and then we would call this function passing in cursor as the source cursor, cursor stable as the target. So we're going from save data to stable, and that's correct because we just deleted stable. We want to create a new one. And then we pass in the save data stable path as the target path, which would do source cursor execute vacuum into save data stable path. So it would go from save data to save data stable, and then it would check the integrity of the new target cursor, which is cursor stable. And then we would do OS remove target path in the case that it was an integritous, and that's the save data stable path, and then it would just go from the source cursor to the target path, which would be save data stable path again, and then else, if it wasn't corrupted, it would break out of that while loop, and yeah, it would just finish that function. Okay, yeah, so I think that's good. The only thing I noticed, though, is we're going to have an issue with cursor, because technically, well, the cursor might not exist, because I'm pretty sure it's not, because we're going to be deleting the database, right? So cursor stable, source cursor would exist, and we can pass that in as an argument. But target cursor, well, no, target cursor would exist. We'd have to create, wait a second, vacuum into target. Well, we don't need target cursor at the beginning. We just need source cursor. And then the target cursor would have to be created inside of the function. Yeah. So I'm going to have to put a note here. We also need to recreate the tables for each file and the associated cursor. Put right here 41025. Note that inside of vacuum into integrity check recreate, we will need to create the table and target cursor. Inside of the function. We won't be able to pass it in as an arg since it doesn't, since at the point of the function call that database file doesn't exist, right? Yeah, because right before we call it, the function that is, we remove the save data stable path altogether. So like we don't, well, that deletes the file. Does that necessarily mean if we delete, let's see, Python SQLite 3, if we create a DB file and a cursor for it, then delete the file, will the cursor namespace still refer to the, well, let's see, then delete the file and subsequently recreate it, will the cursor namespace still refer to the new database file? Will it be valid, or would it have to be recreated? File connections under the hood. Here's a too long didn't read. If you delete the SQLite database after creating a connection and a cursor, the original cursor will become invalid, or at best revert a broken in-memory database. You must recreate the connection and the cursor. So if we did connection cursor, connection is a connection to the physical file, MyDB SQLite cursor is tied to con. If you delete the file is gone, but the other file descriptor inside con is still pointing to a now non-existent file. Any new cursor likely fail or behave oddly. If you're on Windows, even the deletion might fail due to file locking. If you recreate the file, but the old connection and cursor still point to the original file, they will not suddenly bind to the new file. You need to create a new SQLite 3 connect and cursor. So we have to do let's see where. Okay. Vacuum menu integrity check, recreate, source cursor, target path, source cursor, da 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 da, recreate SQLite. Yeah. Alright, so let's go ahead and finish real quick implementing where this function is called. And we can always make those changes after the fact. I want to do this real quick. So I verified this is good to go, except we're not going to be able to pass in the cursor stable. Let's just go ahead and remove that, because target cursor is not going to be able to be passed in as a function. I mean, as an arc, because it's not going to. Let's just hurry up and do this real quick, get it over with. Okay, I see what you have to do. We're gonna take care of that next time. I don't know, I might just go ahead and do it, but I think I'm just gonna do it next time, actually, yeah. I gotta go take a shower. I'm gonna go skate a little bit. Just a little bit in the street, and then I'm gonna go take a shower and all that. Let's see here. So line 98 in save logic. Alright, so we're on the root project directory. We check the branch, we're on the right branch. Now we're going to do git add, git commit dash m. So we successfully committed. We're going to go git push to push to the remote repo. That finished. Alright. So now we can exit out of this and we'll create a local backup. So we'll go here into Canasta, copy this, delete the old one, we'll paste in the new one, and then we'll go to devlog all the way to the end. There you go, that's correct. Now we go back out, and there you go. Alright, dudes. So, good progress. All we gotta do is finish, you know, the task we were on with that. It's easy. It's not hard. We'll be able to finish that tomorrow for sure. And, yep, continue.